Okay, we are going to take a little bit of a break from integration, and we're going to work with today some summation notation, and then over the next couple days some area. And eventually they're all going to connect, but it kind of feels like we're on a random tangent. Laughing?
Wait, I didn't hear. Can you please repeat the joke?
I said it feels like we're kind of on a tangent.
Random. I'm not at what point?
Okay, so today should be fairly easy for you. I need a fork for my lunch. And so, no. There's silverware in the front office that you use.
Your ass. She's borrowing it. She'll return.
Anyway, this is the letter sigma. What does it mean? Summation. Okay, you guys did sequences and series last year in pre-calculus as well as in Algebra 2. You sure did. Now, last year in pre-calc it would have been around Thanksgiving time. That's all right. Let's review some notation. Okay? So, this is telling us that we're taking a sum. This is the lower limit telling us we start plugging in m to k, and we stop, we plug in values to k until we get to n, our upper limit. This is called our index. This is what we're plugging things into. Formula. Okay, so we start by plugging in m, and then we plug in integers until we get to n, and then since we have that sigma, it means we take all those numbers and we, which means we add them all together.
I like
Summon them. You're good at something.
Okay, so we're going to do some basic examples, and then I'm going to show you some properties, and then I'm going to show you some shortcuts.
No.
Okay, so the sum from 1 to 5 of k squared. Brady, what would that look like?
I'm not entirely sure what we're doing here.
Okay, Nathan, I'll let Brady come on, friend.
Why'd you
Go
say
ahead,
Nathan?
Dave.
1 plus 4 plus 9 plus 16 plus 25.
What would it give me?
What's that?
1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. What?
4 square. You never played 4 square?
Yeah.
55.
I just didn't know that's what you were referring to. It's 55?
What in?
You're the king of it.
Okay. How about the sum from k equals 3 to 8 of 7? It is not just 7. It's
7 plus 3.
45. Because we plug in 7. So there's 3, k equals 4, 5, 6, 7, 8.
Plus
Wait, what? 3, 4,
8 minus.
Oh, that's what it is. Okay, because we have 3, 4, 5, 6, 7, 8. There are 6 terms.
Oh, I see.
Because we started at 3, so I said 3, 4, 5, 6, 7, 8. Okay, make sense?
Don't like it when subtraction does that, like, it says there's 5, but there's just 6.
Because you count 3 and 8.
Yeah.
Because we have to include.
I don't like those when you do
Cool with that.
Okay, so these are the 3 that I would like to work through. We'll do the first one together. So 6 plus 8 plus
60.
Okay, Jimmy, what does that add up to?
66.
Oh, I forgot that extra 7.
Yes, that extra 7 up there. Okay. All right, so I want you, without me, to find me this sum.
I'm having trouble writing. Hey, Aaron, I need
You guys have it? What do you get?
49. In my head.
You guys could have finished that one. We were up by 4, like capping with 2 free throws, up by 3, and then I hit 1 free throw in the second one. They called it 15 seconds.
Brady, do you have your answer?
Yes, it's 49. Aaron will drink the last.
Anyone having issues getting to there?
We have 1 second.
Okay. What do you have so far?
5, 5.
Yep.
15.
Yep.
And then.
Okay, and so then we have 2 times 4 squared minus 3, which is 32 minus 3.
Whoa, we didn't start.
Yes.
We have my
Which would be,
Oh, wait.
well, when you add that to your others, because that would be 29, and then plus the 15 plus the 5. Do I need that? Okay. So we have the 5 plus the 15 that you said. And then plus, this is 2 times 16 minus 3. So you have 20.
So how'd you know what to do just
Because it said to start at 2, and then this means to stop at 4. Okay? Now, let's look at this one because it looks a little funky. Okay? Alright. So first we start by plugging in 1. So 1 times the sine of pi over 2. Plus, we plug in 2. 2 times the sine of 2 pi over 2. Plus 3 times the sine of 3 pi over 2. So let's see if we can remember our unit circle. 1 times, what is the sine?
1.
I was going to put somebody in the hot seat.
Okay, next one's on the hot seat. Better get ready.
Times, what is the sine of pi? John?
Great.
Great.
0.
Great.
Plus 3 times the sine of 3 pi over 2. Aaron?
I know.
4. So that was -2.
I got it right.
You all done for today?
Huh?
Bro, we got 9 more slides.
No, it's the sum of 13, which is 1 plus 3 is 4.
Okay, now I just want to tell you about some notation. If I'm talking about a certain term in my sum, I'm going to put a subscript on it. Okay, so B sub k is referencing the sequence that we're summing up. Okay, and so then each of these refer to the specific term in the sequence that we're adding together. Okay, I wanted to show you the sequence so I can show you the properties of all of these summations. Okay, like I know that it feels like we're not doing calculus right now, and some of you are okay with that, but I promise this will eventually all tie in together. Okay, so we will come back and talk about these. Properties of summations. Okay, if I'm adding something with a constant inside, we can take the constant outside, much like we do when we integrate or take derivatives.
But then how would you just factor it in at the end?
You would just multiply it to your sum, yes. Okay, if you are taking the sum of two sequences, if you will, you can separate them out and find the sums separately. Okay. And same thing with difference, because addition and subtraction are very much related. So you can use these to help you. I will wait. Oh, those are good for writing right. Yeah, if you want to combine B and C and write plus or minus, that's fine.
Is there more?
There is more. I'm going to show you some shortcuts. Okay, so how can we use these properties? Well, if you have the sum from k equals 3 to 2k, that is the same thing as 2 times the sum from k equals 1 to 3 of k. Okay, so essentially we have 2 times 1 plus 2 plus 3. Okay. Easy, like if this is a situation where we don't have our calculator, that's all it is here, right?
Oh, here, the calculator.
2 times 1.
Eventually.
I don't know. Okay, now here, okay, since we're subtracting two things inside of our summation, we can break this up into two summations. So essentially what we have is 1 plus 2 plus 3 plus 4 minus 1 plus 4 plus 3. Okay, only to 4. Only to 4. So stop at 16. But see, this is kind of nice because I know 1 minus 1 cancels out and 4 minus 4 cancels out. So we really have 5.
Negative 20. Negative 20. Negative 20.
Oh my goodness.
In fact, that's minus 3 points.
I'm just sneaky like that.
Okay, so, all right, those of you who had pre-calculus here, do you remember we learned this proof technique called mathematical induction?
Yes, I don't
Okay, so we basically proved shortcut. So I would give you a, the sum of a sequence, and you had to prove that it equals
I
something.
think so, yeah.
Like this.
That's,
Oh.
This is something that I know you proved last year. That 1 plus 2 plus 3 plus dot 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 plus all the way to n equals n times n plus 1 over 2. Okay? Now we're not going to prove those because we did that last year. But it's a true statement. We're going to remember it. Okay? So if I have the sum from 1 to 50 of k, I'm not going to sit there and go 1 plus 2 plus 3 plus 4 all the way to 50. Okay, we have a shortcut for that.
It's called a calculator.
Yeah.
I actually use this shortcut often in my everyday life.
Really? How?
Okay, maybe it is.
She gets up and makes
I
coffee.
would-
So you know, like, how is that?
I would say like 3 or 4 times a year I'll use this for something.
So what's
Very
36 times 37 over
That's
7?
where you know you like 1 apple and you have 2 apples.
Well, I can't.
Then you like,
My husband and I used it the other day. What were we talking about? Oh, we were counting up all of our dominoes, and so, because our sons, we have 2 sets of dominoes, and our sons got them like mixed up, and so we were trying to figure out how many dominoes should be in each set.
So what do you do to make sure?
Yeah.
yeah, how would
Or
that
you
be?
just
Or you just
open
the
the
box.
box.
Do you guys play dominoes? Yeah. Okay, so if the numbers go from 0 to 9, right, then there's 10 of each kind, right? Well, if I count all of the 0 dominoes, then I've counted some of the other ones too. So,
Or you just put them all and have just one big game of dominoes. Or you just use them to make.
here's another shortcut. Just never mind. I use it, okay? Maybe it can be helpful to you someday.
Can you show what you did?
Yes, I can show you what I did with my dominoes. There's lots of different dominoes. Some of them go from 0 to 6, some of them go from 0 to 9, some of them go from 0 to 12. We have a 0 to 12 and a 0 to 9 set.
So we just have to memorize this equation.
Yes.
Yay.
Put a penny in every day, but the number doesn't have to be 365.
It's put a penny, like on day 1 you put in a penny, and on day 2 you put in 2 pennies.
Yeah, they didn't specify it here, like, I'm like, I
know.
I say it, and I'll say it, and I say
And
it.
then here is this shortcut. Yes, these 3 shortcuts you need to know.
So we're never gonna have a calculator quiz.
No, I'll show you how to use your calculator if you want.
Just plug stuff in.
why is cube different than square? Like, why isn't the first one, why is the cube one just the first one square?
That.
Why?
Yeah, how come the squared one's like all funky like that, and then the cube one is just.
Is the only odd ones are would K would just be that
I think so, but I don't want to say for sure.
Oh.
And you just break, is there like a reason, like, how do you figure out this now, like a quadratic quantity?
You know, it takes some deep thought.
Oh, I wouldn't have like
You gotta use
I'm gonna have to look that up, okay? I'm gonna have to look it up. I know there is a path, but I cannot remember off the top of my head. So let's practice this. Okay? The sum from 1 to 23 of k.
3 times 24 divided by 2.
So n times n plus 1 all over 2. So essentially we have 23 times 12.
We're gonna have 20.
146.
Oh, look at it.
Around
Oh,
about
180. I don't even know.
100, 200 can,
I don't know.
And
one,
6.
276.
That sounds better.
276. That was close.
The summation from 1 to 7 of k squared.
7 times 8.
Oh, hold on, let people practice.
Whoa there, buddy.
He's got his calculator. He's cheating already.
Some people like to write down the examples. Okay, now Zach, I'll give you your opportunity. How do we set this up?
7 times 8 times 15 plus 6.
Because we have to take n times n plus 1 times 2n plus 1 all over 6. So essentially we have 7 times 4 times 5. Right? Okay, so 6 is 2 times 3. So this can reduce to 4, then this can make it reduce to 5. So 7 times 4 times 5. Do you see that trick?
Wait, can you do that one more?
How come you didn't do it to
Says 140.
Okay, this was me just trying to do some mental math here, alright? 6 is 2 times 3. 2 can go into 8 4 times. 3 can go into 15 5 times. So this is
9 times
essentially 7 times 4 times 5.
What if we have a calculator?
What is this, Jimmy?
140.
Whoops. One more example on this page. Okay, you ready? Okay, what are we gonna do? What's our shortcut? So we have 21 squared is
441.
What? How did you say that?
how did I get 21?
He's like good at himself. 21.
21 squared is not an uncommon thing to know.
Yeah.
It's top of your head.
Well, you take 20 times 20, and you get 100, and then what?
Yeah.
Yeah, sure.
Okay. Now, something like this.
What?
It's already factored out.
K squared plus K.
I like that. I like distributing it. So k equals 1. Okay, I can only write so fast. K squared plus k. And then we have that property that says that if we're adding two different things inside of our summation, I know you did, thank you for the suggestion, Jimmy. We have the sum from k equals 1 to 30 of k squared plus the sum from k equals 1 to 30 of k. And so now we have two summations that we're going to add together. Okay?
You're funny.
So this shortcut. So k squared n times n plus 1 times 2n plus 1 all over 6. And then we're going to add the k the K shortcut. N times N plus 1 all over 2.
5 times 31.
Calculator.
Our friend.
Why is this doing that? No.
Don't be mean before the game.
Okay. So this is how we can do this summation in our calculator to check your work. Okay. So if you go to second stat and all the way over to math, there's this sum right here.
That's the old calculator.
I know, but some of you have the 83s.
Okay.
Okay. Okay, if you have an 84, go to math 0.
Oh.
If you have an 83, okay, Aaron, you have an 83, you have to follow me. Okay, so second stat over to math and hit sum, and then second stat over to operations and hit sequence.
What?
And then we're gonna have to punch in our sequence. And tell it that our variable is x, and we want to go from 1 to 30.
Oh. I can figure it out.
So expression means you plug in like the x times x plus 1. Okay. And then the variable is x. You want to start and
Can I just go like this? Just go math.
I got some, and then we're seeing something
I have it as second.
What the heck, Doc?
Not like me.
I can turn my light on. I'm over there. How do you do that? I can turn it off, say power.
Okay.
So,
Yep.
can you just go to math?
If you have an 84, you can go to math 0. Just math 0.
Hey!
Hey, if you have an 84, just math 0. Get you the
Master race.
summation notation.
Hey, look. Cashew nuts. Where are you different?
Are you getting everything?
It's giving me, saying invalid implied avoidance.
Okay. Go back and after 30, say chroma 1.
After the 30.
Robots.
Okay, I don't know what.
What's it called?
All right. Now what I want to talk about. Okay, I want you to know the difference. This is what we call closed form. This is what we call open form. Kind of self-explanatory.
Hey, Miss, I want to figure it out. I just combined the terms instead of like x, x plus 1, just x plus x.
Okay, awesome. Thank you. Okay. So what we're going to have to do is I'm going to give you a summation that I want to be written in closed form. Okay? So I want to be written basically as a shortcut. Okay? So here we go. Last slide. So I want this to be written as in closed form, really as in a shortcut. Okay, so first of all, let's go ahead and rewrite this sum.
Yeah.
What are we gonna have to do? How about this? We have to FOIL it out. Okay, and then from here, what are we gonna have to do?
Each individual is a
Okay, so we have the sum of k equals 1 to n of 9, plus, I'm going to break it up to 6 times the sum, k equals 1 to n of k, plus the sum from k equals 1 to n of k.
Would be close form.
This is not closed form.
Oh, so then you gotta actually write it out.
Now we need to write the shortcuts. Okay? So let's think about this. If I write... Okay, if I'm taking the sum from 1 to n of 9, we're doing what? 9 plus 9 plus 9. N times. Excellent. This is 6 times. Our k shortcut is what? Plus our k squared shortcut. Oops. Thank you.
Wait, so what, can you just like multiply like for the k squared, can you just like multiply that all out to show me that, like the numerator, and see what I'm saying?
So like, n squared plus n.
Well, see, if I give you an n, if I say, all right, n is 10, then you can quickly plug 10 into there and get your,
But it's n. It's just n.
okay? I don't want you to create more work for yourself. It is just as easy to evaluate like this than it is if we multiply it all out. Like, it's not gonna be a time saver for us, so
Good question.
we'll just say like, we'll just leave it like this.
It was a good question.
It was a good question. Brady was being an encourager.
Oh,
Encourager. Encourager.
I'm a encourager as well.
Encourager.
We build each other up.
Have you not seen
Do you know that song?
I've seen the edge, yeah, but I didn't know
That's
exactly
what you're talking about.
Yeah, like-
Then I'm Mr.
Now that's where like in story problems.